Unit 1, Lesson 3. In Algebra 2, we will spend a lot of time evaluating and simplifying algebraic expressions. So just to be clear, why don't you pause the recording and write down this definition in your notes. Algebraic expressions are just combinations of constants and variables using the typical operations of addition, subtraction, multiplication, and division, along with exponents and roots, such as square roots and cube roots. In exercise 1, you see a common algebraic expression that you may use as an example of what one looks like. It is important to be able to evaluate algebraic expressions for values of the variables contained in them. In exercise 1, we are given the algebraic expression 4x squared plus 1. So let's describe the operations that occur to x within this expression, and what order would we evaluate them if we had a number to plug into the variable. The first thing that we would do is we would square whatever we plugged into the x. After that, we would multiply by 4. And then we would add 1 to that product. Part B asks us to evaluate this expression by replacing x with the value of -3. Show each step in your calculation, and we don't need to use a calculator for this one. So a good rule of thumb whenever you are going to evaluate an expression is to plug the number into the x and write the expression as you see it. So I'm going to use parentheses around my -3, and I'm going to remember that it's squared plus 1. Now, based on our planning that we did in Part A, we are going to square the -3 first. Now remember, when you square a negative, it becomes positive. So I end up with 4 times 9 plus 1. 4 times 9 is 36. And after adding 1, I end up with a final value of 37 for this expression. Exercise 2 gives us a more complex algebraic expression that's in fraction form. When I see that, it is a rational expression. Again, we can evaluate this one without our calculator, and in Part A, it wants us to replace x with the value of 3. Again, let's start by just plugging in 3 where we see the x. I'm going to use parentheses to show my multiplication. So I have 4 times 3 plus 3 in the numerator of this fraction. And in the denominator, I'm going to have 3 cubed minus 7. Now, to evaluate these rational expressions, I tend to evaluate the numerator, the top part of the fraction first, write down that answer, and then evaluate the denominator, the bottom part of the fraction. So by following my order of operations for just the numerator, 4 times 3 is 12, and 12 plus 3 is 15. So I get 15 for the numerator. On the bottom, I have 3 cubed. 3 cubed means 3 times 3 times 3, which is 27, and then minus that 7, I'm going to get 20. Now, this is an answer, but it's not in the simplest terms. When it asks for you to provide your answer in simplest terms, you want to reduce your answer. So if I look at 15 over 20, I notice that 5 goes into both the 15 and the 20, and I can reduce this to 3 over 4. Now Part B is asking you to take note that when you're evaluating expressions, you may want to be careful by when you check them in your calculator, because sometimes what we plug into our calculator is not exactly what we're thinking. So take a moment, pause the recording, and plug in Part B into your calculator and see if you get the same result that we got in Part A. If you did not get the same result, which I'm thinking you may not have, can you see what was wrong? So in other words, if you just plugged in what was on the paper exactly, so what you see right here, as you see it, 4 times 3 plus 3 divided by 3 raised to the 3 minus 7, Why did we not get the 3 over 4, or maybe 0.75 depending on the type of calculator you're using? Think about your order of operations. If we were to do order of operations correctly and by hand, what would be the first thing that you would do? Well, it would probably be this exponent piece here, 3 raised to the 3. And then you would go through and get rid of all your multiplication and your division. So you would end up multiplying the 4 times 3 here, getting the 12. But then you'd also have to do this division. 3 divided by 3 is 1. And notice that you then aren't dividing by the whole denominator that was originally there, this 3 cubed minus 7. And we aren't even dividing the numerator as a whole. So be careful when you plug things into your calculator. Your calculator will do order of operations and may not follow the steps that you were thinking. Let's look at some other expressions that can use some different type of manipulating. In exercise 3 down here, we're going to be using the absolute value expression. So in exercise 3 it says, is the absolute value expression, the absolute value of x minus 8 plus 2, equivalent to the absolute value of x plus 10? How can you check this? So let's remember, absolute value is going to find the distance a number is from 0. And we're going to use the absolute value bars sort of like parentheses. So we're going to do whatever's on the inside first. So in this case, they didn't ask us to plug a value in for x, so we can always choose a number to plug in to check these. So I'm going to use x equals 1. And I'm going to plug 1 into x for both of these examples. So over here, I'm going to have 1 minus 8 plus 2. And then over here, I'm going to have the absolute value of 1 plus 10. So 1 minus 8 gives me negative 7 over here, plus 2. And when I take the absolute value of negative 7, I get a positive 7 plus 2, which means that this whole expression ends up having a value of 9. Over here, the absolute value of 1 is 1 plus 10. This expression, I get a value of 11. These are not equivalent expressions. They do not give the same value when evaluated. And I plugged in 1 to both of these and I did not get the same value. So they are not equivalent. Exercise 4 uses the square root symbol. So let's consider the algebraic expression the square root of 25 minus x squared. Let's evaluate this expression for x equals negative 3. Remember, we are going to be working with a negative number. So always be a little bit more cautious when you're working with negatives. So what I did is I plugged in negative 3 into x, and I'm going to follow my order of operations. So order of operations says to do exponents first. So 25 minus a negative 3 squared, negative 3 times negative 3 is going to give me a positive 9, but I'm subtracting that positive 9. So I get 25 minus 9. 25 minus 9 gives me the square root of 16, which will give me a value of 4. Part B says, why can you not evaluate the expression for x equals 13? Well, let's take a look at this and let's plug in 13. So I have 25 minus 13 squared. Well, 25 minus 13 squared is 169. When I do 25 minus 169, I get a negative 144. What does that mean if I try to find a square root of that? If you recall, you cannot take the square root of a negative value and get a real answer. And we'll talk about more about taking the square root of negatives later on this year, but for right now, our understanding is that we cannot go further because we are not allowed to take a square root of a negative number. There is no number times itself that'll give you negative 144. So moving on, Max thinks that the square root operation distributes over the subtraction. In other words, he believes the following equation is an identity. This is interesting. So what he has on the left side is the square root of 25 minus x squared. But on the right side, he has 5 minus x. So what he means by distributing that square root is he took the square root of 25 and got 5, and then he took the square root of x squared and got x. So he's hoping, or he's thinking, that this is going to be an equivalent expression, meaning equal on both sides, and that it is an identity. We're going to find out that it may not work out like what he's thinking. So let's use this value of 3 that we used above. So on the left-hand side, I have 25 minus 3 squared, just like what I did above. So if we kind of check this with x equals 3. And on the right-hand side, I will end up with 5 minus 3. So based on our work in part A, we found out that 25 minus 3 squared was 25 minus 9, which gave us the square root of 16, which resulted in a value of 4. Well, over here, 5 minus 3 is 2. These are not equivalent, so this is not an identity. Algebraic expressions can become quite complicated, but if you consider the order of operations and work generally from the inside to the outside, then you can evaluate any expression for any replacement values that you plug into the variables. Exercise 5 and 6 are rather complicated expressions, so we just have to take our time as we work through them. Again, pre-planning can be helpful. So in exercise 5, part A, it asks for you to think about what operation would come last if we used order of operations. So that idea of working from the inside to the outside would mean that I'd go into this square root and start working on the inside part. So I'd be evaluating what's underneath that square root first, which means the last operation that we would be doing would be the square root. So let's try this. Evaluate the expression for x equals 2. And let's simplify it completely. So if I take this expression, again, it's going to be a little bit big here, and take and plug in 2 into the variable. I'm going to copy this down with just the 2 where the x is. So the absolute value of 2 minus 8 is underneath that square root sign, and that's over 5 times 2 squared plus 4. Now again, I'm going to work on my rational expression underneath the square root sign separately, and I'm going to work on the numerator first and then the denominator. So I'm going to do the absolute value of 2 minus 8. Well, 2 minus 8 gives me a negative 6, and I'm going to take the absolute value of that and get 6. Okay, and this is all going to be underneath that square root here. So on the denominator, I'm going to do 2 squared first. So I'm going to be evaluating this exponent piece first. 2 squared is 4. 4 times 5 is 20 plus 4. So I'm going to have 20 plus 4. So that's going to give me 24 here. So what I end up with is the square root of 6 over 24. Now I'm going to simplify 6 over 24 first. 6 over 24 can reduce down to 1 over 4, because 6 will go into itself once and go into 24 4 times. 1/4 I can take the square root of. I can take the square root of 1 and get 1, and I can take the square root of 4 and get 2. So my final value is 1/2 here. Again, just take your time, look at each part separately,